All right, the recording is on. So, hi everybody, welcome to the KubeEdge community meeting. It's April 1st, 2020. So this time the community meeting is Europe time friendly. I think we can first go through the v1.3 development updates, and then we have a demo here. Let me turn on the screen sharing. Okay. Okay. Please, every attendee on the meeting drop a line in the meeting notes in the attendees section. Okay. Let me send the meeting notes also to the chat. Okay, so this time we can first go through the development update. I created one spreadsheet to track the ongoing features and enhancements. So basically, it's just summarizing the items we are discussing repeatedly every meeting during this release. Okay. So I will just briefly go through the spreadsheet, and please every assignee to give updates about the enhancement. So CRIO, we have a tracking issue, and currently no proposal yet, no pull request yet. HA support, we have proposal currently under review, and implementation pull request not yet submitted. Logs and the EXEC, we have the proposal reviewed several times, and the pull request is not yet raised, but I think it's under development. So the metrics support at Edge, no proposals yet, but there's the implementation pull request is already there, so we just need to review. The Golan upgrade, this I don't think we need a proposal, but the pull request is there. So one thing may be that we can wait for the Kubernetes upstream to upgrade to Golan 1.14. And next is the gateway support. We have a proposal there, but pull request are not yet raised. Edge mesh refactoring, we have first pull request already accepted, but there are still several work need to be done, so we need to update. The support installation on CentOS is already in, so we will just need to update some documents. And the node authentication is currently on the review of the proposal. Okay, so this is just what we have currently in the feature tracking spreadsheet. Please, everyone, feel free to add items if you have anything to add. Okay, so let's go through the updates. I will just invite the feature owner to provide the updates. So first is about the HA support for Cloud Core.
Wait,
Yes, well, I
wait,
can
wait.
hear you.
Let's show my screen.
Okay.
Uh, can can you see?
Yes.
So the motivation of Cloud Core high availability HA design is KubeEdge is designed to serve hundreds of edge nodes and is ob- obviously single system could hardly run well all the time, and ideally it should be HA. So our goal in Alpha, we should support Cloud Core crash restart and support HA in hot standby mode. And in beta, we should realize HA in stateless mode. It means multiple cloud cores should serve at the same time, and cloud core no longer a performance uh, bottleneck if the number of each nodes increase. Uh, Let me say the design detail for Alpha. At present, the Cloud Core is essentially an edge resource distributing center, which encapsulates resource objects into message. The dest node of the message is recorded in message.router.resource, and there are four type modules which could generate a delivery message from cloud to edge. The first is downstream in edge controller. When downstream init, it will watch all port events and picks out port event which is assigned to each node. And the nodes labeled by node row kubernetes.io edge. And because of pod.spec node name, downstream could directly build a message router.resource when generate pod related messages. But for config maps and secrets, there is no such similar field. So when downstream delivery pod, it will check if the pod refers to config maps and other secrets, and record config map names and secret names and their dest node, the list of each nodes and the list of config maps and the secrets to dest node are recorded in location cache at resource distribution route, which is declared below. And the second is upstream in edge controller. When edge node get the pod from cloud, it will check if there are relative config maps and secrets in edge store. If not, it will send a query message with node information to cloud, and upstream will respond. So upstream in edge controller need not a location cache. The third is the device controller. Currently, only device need to be sent to each node by device controller. The device-related events are all assigned to each node, and device spec is recording the information of dest node. So device controller do not need a location cache. The fourth is sync controller. Sync controller will periodically compare the saved objects resource version with the objects in Kubernetes and then trigger the events such as retry and deletion. all resource that has been left out will be sent to each node again and again by single controller. Data needed for single controller running properly is stored in etcd as CRD. So when cloud call crash and restart, according to the description above, all the data that cloud call needs to run properly is location cache and sync CRD in etcd. For the former, cloud call will trigger the initialization of location cache when it restarts. For the latter, cloud call crash does not affect information in etcd. So message left out during crash will be resynced when single controller reruns. So HA in hot standby mode. The first we need leader election. Referred to HA in controller manager. There is a list type in Kubernetes as the name suggests. Its role is to create a resource with a list. Suppose there are multiple nodes that want to compete for the leader. Then everyone first tries to create this list resource. If the creation is successful, then you are the leader. A successful creation does not mean that you have always been a leader. You have to renew your list regularly. List duration seconds. If you do not renew your list will expire, and other participants will preempt the leader's position. Relative code has already in Kubernetes gone client go. Just show there. And we need a health check and a leader check port for load balance. We should expose health check service for load balance as well as whether the cloud core is leader and what does the leader do when cloud core is leading. It should renew the list resource, and when it is preempted the leader position, it should stop serving and turn off. Wait for next restart. What the follow do when it is falling? I think it should stop delivery, but still list watch API server for updating location cache. And if a request is still received, just pass through the leader to the leader, and keep trying to persist list lock. When it preempted the leader position, it should disconnect all edge nodes and wait for a new connection request and started to deliver message to edge nodes, and the sync controller ensure resending message during switch. That's all. Thanks.
All right, thanks. Any comments or questions? So I just want to confirm that the Markdown document is currently in the pull request, right?
Pardon?
I want to confirm that the Markdown currently you are showing is the same one in the pull request, right? Because you are You are not accessing from the pull request.
Yes, it's the same one.
Okay. So have you taken a look at the PodReady++?
I haven't.
Okay.
I'm going to be look at that.
Yeah, I just want to add that so the leader check why we need that, because when running inside the Kubernetes, we will manage the Cloud Core instances with deployment. So typically, deployment controller will just check if there's enough there are enough pods running, and all the probers probers track are working well according to the replicas. So that means that the probers of the pod need to return true, basically true for the checks from the deployment. While because we are implementing active standby mode in the alpha release, so typically from the load balancer, there's only one pod uh, running at the same time, serving all the connections from edge at the same time. So from the load balancer view, it need to know which pod is the leader, basically. So that's why we need a leader check here. And to integrate with Kubernetes and take the most reuse the most functionality of Kubernetes, we may probably use PodReady++ because that mechanism introduces a way from checking from the very external load balancer inside, and then to the pod to check if each route is working. So basically, the PodReady++ will just make sure the pod ready to serve can receive and proceed the request. Okay, I have another question about the last section. You, in the proposal that you for the standby instance, shall we just block the whole process? Make it with until it becomes active, then it can finish the like in initiation and start list watching.
There.
I mean, when it's not active, but you keep list watching the like the API server, you definitely need to kind of have a switch to manage. When it's active, it's kind of continue from a middle state and to serve all the connections, right?
Pardon?
I mean, so for a standby instance, maybe you can just from the very beginning block all the things from the very beginning and make it only able to serve the leader check. I think that's much easier.
Yes,
Leader
yes.
check and the health check.
Yes, yes. I think so.
Yeah, and another thing is that about when the leader becomes when the standby becomes a leader, maybe it doesn't have to disconnect all the things, disconnect all the edge nodes, because when it's standby, no no request will reach the standby instance, right? And all the logic you actually uh, are are blocked, so no connection before it becomes active.
Yes, if a follower did not serve at the very beginning, uh, we we need not to disconnect all the edge nodes.
Yeah. Okay, that's all from my side. Anyone have any questions or comments about this proposal? Okay, if not, we can move on. All right, the next is matrix support. Shufei, would you like to give updates?
Hello?
Yes, yes, we can hear you.
Okay. Let's share my desktop.
Okay.
I have set a PR to add the metric interface at the edge. Previously, the edge code don't support the kubelet metrics interface, so we can't collect the metric data at the edge. So I added them back in this PR. So now we can use the kubelet metrics interface to collect the metric data. Like this, we can curl this interface to collect the metric data. This is changed with after I add the seed-wide based metrics. First is the binary size change. This uncompressed. The binary size is changed from 92 M to 105 M. Yeah. The second is the memory change. Memory change is to first is when we have 0 port, the memory is from 64 to 72. The second is when we have 100 ports, the memory changes from 72 to 96. Yeah, this is the memory change and the binary size change. Yes, now let's see. Yes, I have. Yeah, this is my branch. I have run a local cluster. Yeah, we can. Let's see the. Yeah, we can curl this to get the matrix info. Yeah, but yes, but now you can see I have run a pod to the edge node, but now the pod info in the summary is empty. So now I'm still debugging this issue. Yeah. That's all. This is the first time. First time I just add the matrix interface at the edge. The next step, we will support the matrix server in the cloud. Yes, yes, I have right here. Next step, we will support matrix server in the cloud. Support collect monitor data from the edge through the edge cloud and edge hub. Yes, we will through the hub to collect the metric info. Yeah, this is something like the logs and ETC.
Hi, Shifei.
Hello.
Yes. So I just want to make sure what's the meaning of the memory change. So is that me? With this feature, the memory will that consumed will be increased from the 1.64 to 72.
Yeah. Yes, the memory will change.
No, it's not 1.46 1.64, but 64 memory megabytes. The one dot means when there's a zero,
Okay.
no pause one. Yeah, it's confusing.
Okay. Yeah, yeah. So that's not a very big change. So that's good.
But with 100 port, this is not very small.
Yeah.
I think that's kind of fine because when if people want to manage 100 ports, there will be more resource at the edge. So that's kind of not very sensitive at that time.
Yes,
And actually, you can also add the feature flag, feature gate for the metrics. So if people have that other implementation or other way to collect the things, maybe they can just turn this off.
Yes, we have started the set riser now. Now I have added another configure field to so user can disable the matrix, so the memory will stay as before. Yeah, I have added this configure.
Does KubeEdge has something like feature gate, which is currently we used in Kubernetes?
Yeah,
you mean the feature gate name, or?
I mean, in Kubernetes we can turn off some features by feature gate, but I'm not sure whether we can do this in the KubeEdge or we need to implement this feature in KubeEdge.
So the feature gate, Kubernetes have a framework of feature gate, so that's widely used when the contributors add especially new alpha feature, so people can turn off if the alpha implementation have any issue. The feature gate will typically removed when the feature is moved to stable, or as known as GA. But here I think it's the idea is that we can reuse the idea of feature gate, so user can turn off some of the features in different case.
Yes, I think we can add the feature gate, but in this case, if the feature is GA, we need still can disable the matrix if the user don't need the matrix in edge.
Yeah, I think it should be fine with some flags here.
Yeah. So this is read to the memory, the edge.
Cool.
Okay, that's all.
Oh, sorry, I was mute. Okay, so if nobody have question about the metrics, we can move on to next. So about the edge mesh, we have the first pull request merged, and also we have some work to do in the follow up. Shifei, would you like to give updates about the edge mesh?
Oh, okay. Let's share my display. Yes, we have a refactor of edge mesh have merged today. Yes, now we have some refactor to the edge mesh. It has been merged now. The big change of this refactor is that now we don't have init container to every pod. Now we have now we will have like one init container in a host. So you now user no need to configure the init container to every pod. Yeah. There's some other improved to the edge mesh, like we add some cache
But the cache is the cache currently in this pull request, or it's not in? Maybe we need follow up improvement about this.
Not add a cache in edge mesh, but we need more improvement for this.
Yes. Yeah. Okay. And also we need to update the document because it's we removed the init container, so there'll be a big usage change. Right? Oh, okay. I see the document. It's already updated.
Have some change, but we need more details to this.
Yeah. Yeah.
Yes, now we have deleted this, all this init container config in the pod. Okay, so I think need to add more details in a document.
Okay. Any question about the edge mesh? Okay, we can move on. So the next will be the node authentication. So node authentication, we already went through the proposal last meeting. Is there any updates this time? Okay, if not, maybe we can just move on. Let me double check if anything. So the gateway support currently no implementation no implementation yet. So we can wait for wait until next time. And another thing is about the cryo integration. Dave, do you have any updates about this? Hi, Dave.
Hello? Sorry? Okay.
Do you have any updates about the cryo integration?
Currently, I'm still working on the verification. Yeah, I tried the container D as a runtime, but it seems like it doesn't work in my side. The port is always pending, and I didn't see the pod, the creation of the container actually passed to the container D. So I'm still troubleshooting. So I don't think there is a big problem, just maybe some configuration or something else I need to figure out.
Yeah, I think so. So because we already support a container runtime interface, so I think the most of the work should be just verify and improve the document, right?
Yeah.
And also, I also had to try to install Cryo yesterday, so it's I have to manually spin up the Cryo. I'm not sure why the installation just get me binaries but no services. So I started it. It looks like it takes only around 30 megabytes of memory, so it's quite light.
Okay.
I also know you tested the CRI thing, but maybe, yeah, let's see. Okay, so I think in total, if we like weigh the most of the memory usage increasement during this release may be introduced by metrics and probably some of the implementation of EXEC and the logs, but it's not that big. For the users that have sensitive resource requirement, maybe they can choose to integrate with CRIO. So that will be, in total, I think the footprint is still smaller. Okay. So I think that's much about the 1.3 development updates. Anyone want to chime in, or we can move on to the demo?
So Kevin, I have one small request. I am just had a look at the make files, which is the make file in the hack scripts. I would request to the maker of the make files and the hack scripts that if it would be possible to include some comments in the scripts, because like right now I couldn't make sense that, okay, which script is used for what and how is the control flow going on in that make file. So if someone could take out time, who is the writer of the hack scripts or the make file, to just include a one-liner above each file that okay what that particular file is doing, or like one line above each function that okay what that particular function is doing, that would be quite very helpful.
Yeah, about the makefile and the build scripts, I think Jen and Zhang Jie has some experience on that. Okay, they are on mute. That's fine. I will just ping them to. So basically, you're asking to add some comments, right, in the code, right?
Yeah, you remember like I'm trying to create the Debian packages, and you asked me to include it in hack folder. And now basically there are a few commands which I need to put it in the makefile, like fpm to create the Debian packages. However, what I can do is like I can put it in the makefile, but I think there is a better way of doing it in some hack scripts, but I don't know which one. And like it's very difficult for
So
me
basically the main script need to be in the hex, and the makefile we can just add one line or two. That's kind of entrance to call the scripts.
Yeah, I saw that that okay, basically you can call the scripts, which is not a problem. But like for example, so I can call the script to create the initial one folder where all the document where all the files are. But to create the Debian package, I know I would need it to create the Debian package after each build, like for make, for cross build, for ARM7, ARM8. So that one liner has to be in the makefile or after the command, or like make cross build. So like a little bit documentation in the scripts would be a little helper. Otherwise, if that is too much work, maybe just ping me the names of the people who has done it, and like maybe I can just add one liner in that the command.
Okay, I think the makefile is updated last time by Zhang Jie and Xu Fei, right? So maybe we can schedule a breakout discussion about this to just go through the details.
Perfect, sure, thanks.
Okay. So we can move on to the demo. So the demo this time will be the facial recognition by Xiaoling Su.
Oh, yeah, I'm here.
Hi. Can you share your screen?
Okay. Hi, everybody. I'm going to show you a simple demo of emotion recognition on KubeEdge. Here is a simple architecture diagram. In the Kubernetes cluster, I deploy an emotion server. It will receive requests and recognize the emotion. On the edge side, here is a client service, which will catch image from a camera and does a face detection. When detected face, it will send an emotion request to the server and then show the response on the display. The edge side is a Raspberry Pi. I connected a camera and it connected to a display. the Raspberry Pi connected were added to Kubernetes cluster by KubeEdge. Now I will show the program.
Just a quick intro. Can you give an introduction about what does the emotion server do and what does the emotion client do?
Okay, the emotion client capture image from the camera, and it will detect a face. When detected face, it will send a request to the server. The emotion server will recognize the emotion and respond to the client.
Okay.
When the emotion client receives the response, it will show it on the display.
Okay, thanks.
It's just a simple demo.
Yeah, I think you can move on.
Oh, okay. Here is my Kubernetes cluster. There are 3 nodes. One is a master, one is a node, and the other is the edge node. I have already deployed the emotion server on the Kubernetes cluster. It's on the node of the cluster. Now I will deploy the client service. I will open my camera. You can see the image. Hi. Now I will show. Here is the Raspberry Pi. It's with a camera, and I connect a display for it. Now I will deploy the client service. The service will schedule to the edge side node because I specify the node selector to the edge node. Wait a moment. And now it's running. You can see the image on the display. Now you can see my face. when I change my expressions. Okay.
Can you move the camera a bit closer?
Oh, it's
Some guys may don't understand the Chinese, so they don't know what happened.
You should display the in English.
yes. Yeah. Now the but you can see the change.
Okay, it's peace and calm currently. Maybe you can change another emotion. Okay, it's happy.
Yeah, happy.
All right. Yeah, I think that's a very good demo for the studying. Can you also give a brief introduce about the like the frameworks you are using for the facial recognition?
This program was coded by my college in other department. I don't know it very much. But I know some of it. The face detector, they use the OpenCV. And now the model is running on Onyx runtime. I just know that.
Yeah, I think that's very helpful. And also, currently, are you using the CPU to capture the picture and also do the analysis, right? Or are you using GPU in the cloud?
Oh, just a CPU. The node is a virtual machine, and the edge node is just a Raspberry Pi.
Okay, then I think that it might be very easy for others to reproduce if people want to try. Will you contribute this demo to upstream, or you can't?
It's not code by mine, so I need their pro of my class, my college, but there are other department. I don't know now.
All right, or maybe just a brief document about how to build the things should be very helpful, because facial recognition or emotion recognition, the inference application, maybe developer can develop by themselves.
Oh yeah. I will do it later.
All right, thanks.
Yes, in this demo, I think we can upload the emotion data to the cloud, so we can monitor emotion in the cloud. So our device CID.
Any other questions about this demo? So the last question is about are you using device CRD to send the picture to the cloud? Is that your question, Xufei?
I think we can always send the emotion like happy to the cloud, so we can.
Oh no.
No. We
Uh,
don't need to upload the picture.
Oh, you mean doing the influence at the edge, right? Instead of in the cloud.
But just some message like happy, not happy.
I really don't know it very well.
So we can see your emotion through the CID event cloud.
I don't think so. The client is connected to the server directed and gets the response. I don't know the detail of it.
Yeah. Okay. I think so. The further step about this demo is actually what we discussed in the meetings before. Also, a few people are working on a blueprint in the Acrino community. It's called the AI offloading. So, as you know that the edge have some of the computing power, so you can basically do some simple inference in the edge, while there are heavy workload to compute. You can basically offload the tasks to the cloud. So the task so the application in the cloud can do the complex analysis. So if you like in this demo, you are just doing the facial recognition, the emotion analysis in the cloud, but the inference at the edge is quite simple. So you just detect the face and cut the picture, right?
Yeah.
Yeah. So actually, it's also kind of the AI offloading, because you cut the picture, make the data smaller, right? So.
Pardon?
I mean, you have an application at the edge to detect the face, so you just send the picture of face to the cloud. You are not sending the whole picture to the cloud.
Oh yes, that's right.
Okay, that's all from my side. Anyone have any question about this demo or?
So Kevin, if we have some time, I can show you one very quick demo in like 5 minutes.
Yeah, I think we still. Actually, we have. So I personally have some time. If that's fine, we can go on.
Okay, so if you are okay, I can show you some quick KubeEdge thing which I have been doing.
Sure.
Okay, so I gonna.
All right. So I just want to thanks again to Xiaoling for your demo. Thank you for your demo, and so
that's all.
Yeah, let's invite Vijay to share the screen.
Okay, perfect. Okay, so basically I'm doing home monitoring as of now. I have 3 sensors in my house, one in basically bathroom, living room, and bedroom. And I measure VOCs, ECO2, PM2.5, PM10, PM1, temperature, humidity, barometric pressure, light, noise, etc. And I'm plotting this on a Grafana time series database. And based on the dashboard, I'm also like providing information such as like, okay, if this is the value, what could be the health impact of that particular value at that point of time? Similarly for VOCs, if you see like, okay, there are like what value, okay, if you have an exposure of 1 hour, what could be the health effect of it? Also, like there are a few things which are recognizable by this is if you are cooking, the VOCs and ECO2 or the PM2.5 basically increases at that point of time. So like these peaks which you are seeing are during the cooking times. Okay. And although this, if you see, this IP is on the cloud, however, because I deploy Grafana, Docker, and InfluxDB Docker on the edge also. So if I give you a Raspberry Pi and some sensors to monitor your home environment, you can view the data locally rather than on the cloud. Okay. Any questions here? We are good.
So currently, the data is stored in the cloud, right?
Both ways. I store it in the cloud. I store it in the edge also.
Okay. So are you using device CRD or device train to sync the data to the cloud, or?
Not really. So basically, the way I do it is just a sec. I think I have to do a new share. Hold on. So. Okay. Yeah. So if you see, I'm basically having multiple nodes. Each node represents one house, which you can say. And then I have daemon sets running on each of the nodes. So I have 3 daemon sets. If I describe each daemon sets, basically on the daemon set pods 1, I'm using using Zookeeper and Kafka and Mirror Maker. So Zookeeper is so Kafka is basically the message queuing, which is storing all the database locally. Mirror Maker is basically sending all the data to the cloud. Then you have daemon set pod 1, which is basically MQTT Kafka. So like the sensor sends the data to the MQTT server, and from there it is sent to the Kafka. And then you have Influx DB and Grafana daemon set, which is basically creates the dashboard. So because I do it locally also, so if I go and browse the local Grafana server, I should be able to see the database as of now also. Yeah, and because all of my nodes are mostly Raspberry Pis, and then currently it is breaking on 1.2.1. That's why it's all not ready as of now. Otherwise, everything is like it works fine as of now. So yeah, that's it from my side.
Okay, thank you. So we are running out of time. Anyone have any question to discuss, or otherwise we can finish the meeting today? No? All right. Thank you everybody for joining the meeting today. So I still don't see the attendees. People have left their names, so please don't forget to to leave your name there. And the next meeting would be April the 8th. It's the Pacific friendly time next week. So see you and take care until next time.
Okay.
All right, see you.
Okay, fine.
Bye.